Hi everyone, welcome back. This lesson will focus specifically on automated or bot trading in crypto and in other financial markets. Here's an overview of the lesson. We'll first start off with a general introduction to automated trading, what it is, how it works, how it affects cryptocurrency and other financial markets. We'll have a brief overview and an introduction to what algorithms are. Once again, this isn't a coding class, but just to have a general understanding of what they are and how they work from a trading perspective. We'll take a look at high-frequency trading and how it affects cryptocurrency markets and other markets. And we'll also look at different types of trading bots and trading strategies implemented with them. So, cryptocurrency markets are notorious for their volatility, where asset prices can see extreme fluctuations even in the span of a few minutes. We see prices quickly go up and quickly go down, just as fast, if not faster. Now, these global markets are also open for anyone around the world to participate in 24 hours a day, 7 days a week. Crypto markets never close like the New York Stock Exchange does, or the Shanghai Trading Exchange, or the London Stock Exchange. These traditional exchanges, they close. They're only open for about 7 hours a day, give or take, not counting extended trading. But typically, they're open for a preset amount of time, and then they close for the rest of the day. Crypto is open 24 hours a day, 7 days a week, even on weekends and holidays. Now, these factors, especially the fact that crypto is open 24 hours a day, limit the effectiveness of human trading in crypto in several ways. Traders can't react quickly enough to changes in price to achieve the most optimal trades that could be made. The fluctuations and the volatility at times is too much for a human to handle, for most humans to handle, right? Sometimes it's just too quick to read. Things just are happening too quick. Exchange slowdowns and transaction wait times only make this issue worse. If you are experienced or a veteran, and even if you're not, this is something you'll quickly learn, is that sometimes exchanges will go down, especially in times of extreme price increases or price decreases, times that you need it the most. When you want to put in those orders to buy and sell, the exchanges will go down because so many people are using the servers, and the exchange gets overloaded, and as a result, is not able to be used. Sometimes transactions are halted, not necessarily intentionally, right? It's unintentional. They're not necessarily halting trading. It's just that their infrastructure can't handle that much use at once. There's also the fact that crypto is open 24/7. Traders can't reasonably dedicate the time to crypto markets to always achieve the best trades. At some point, you have to eat, you have to sleep, and you have to live your life, right? You have to actually go outside and not stare at screens all day. So this is definitely an issue when it comes to completely tracking Bitcoin and being able to take advantage of all of its shifts and turns at all hours of the day and night. Now, one of the available solutions to these issues is the use of bots, or automated tools that perform trades and transactions for the human user. These tools or bots can be used to take advantage of crypto markets, as they can run 24 hours a day, 7 days a week. You don't have to actually sit there and watch screens the entire time that these bots are running. And bots can also react to updated data, analytics, and pre-programmed buy and sell conditions faster than a human trader. As fast as your computer can run, as fast as it can process these commands, and as fast as the program that is made to process these commands is how fast you can react, which is definitely going to be faster than a human trader, which is prone to human error, exhaustion, emotional influence, and more. So algorithms, which are really the backbone of trading bots, these are sets of steps that define a sequence of actions. Sometimes they're referred to as algos for short. can be thought of as a set of commands designed to solve a particular problem or to achieve a particular goal. Algos consist of a clear sequence of instructions that tell computer programs to perform a variety of tasks. And this can range from simple operations such as subtracting two numbers, or more complex operations such as entering and exiting multiple trades on a cryptocurrency exchange at the same time. Now, every algorithm is made up of a fixed beginning and endpoint, which is basically saying, hey, there's some sort of input, there's some sort of factor or a scenario that must be met for the algorithm to be put into action, and then the endpoint would be the output, where it would actually end and to achieve what result, right? We're producing an output according to the inputs and to the predefined steps. So at some point, we are creating condition that, let's say for trading, we want to have some sort of trade condition where if Bitcoin drops 10%, we are automatically going to buy. And if Bitcoin were to increase 5%, we're going to automatically sell. So you have some sort of beginning, you have some sort of endpoint, and you have predefined steps that the bot will take to either buy or sell, or how to manage that trade. Now, multiple algorithms can be combined to perform more complex tasks at the cost of more computational resources. And this is really where the efficiency of the bot program you're using and the efficiency of your computer come into play, right? Stronger computers, better, well-made, automated programs are going to have an advantage over computers that may be 10, 15 years old, aren't as fast as the most up-to-date computers, and maybe also these systems that are using the more out-of-date or maybe inefficient bot trading programs. Here's an example of what algorithm and coding may look like. This isn't necessarily limited to just trading, but this is just an example of the backbone and the infrastructure of an algorithm and the creation of a program that is automated, where you have encoded set conditions that the program will essentially read and look through in order to process what sort of transactions need to be processed. Now, algorithms can be measured or rated based on their correctness and efficiency. Correctness refers to the algorithm's accuracy in regards to code structure and whether or not it can solve the desired problem or reach the desired target or result. Now, efficiency refers to the amount of resources and time spent to perform to the desired task, right? So now we're starting to measure these algorithms. We can start to compare algorithms, compare the trading program itself based on how accurate it is and how efficient it is. Is it going to take a longer amount of time? Is it going to use much more of the processing power? Is it going to take more energy to run these programs and to run the computer during those times when the bot program is being run? Especially if you're doing this on a large scale, this is something that you have to consider.